Hi everyone, this is Rashid Kibria from Fixed Research, University of Florida. In this demo, I will try to analyze the complex memory controller core. This core I have already taken from opencourse.org, and I will try to analyze this using my developed ARC-FSM-G tool. As you have already known that ARC-FSM-G tries to analyze the gate level STG of the control FSM, which was generated by FSMS Ultra, and it identifies security bugs there. This controller core is very complex because it has total 66 states. For this version, I have taken the binary encoded version. So all the FSM states, they were using directly binary numbers. And that basically starts from 0 up to 100, 0 up to say 65. Yeah. You can synthesize that using Cadence Genus or Synopsys design compiler. And after that, you have to run FSMS Ultra to extract the gate level STG of the control FSM from the entire core. And that gate level STG is already stored here. So GL underscore STG underscore 1, it holds the information of this state transition graph. And there are also the other things, this statistics file. This statistics file is also generated by FSMS Ultra. It contains all the information related to the FSM that is present in the netlist. So here you will see the state register name and also some other relevant information. For example, how many, what is the count of the state flip-flops there, and also the FSM probability metric, and how many gates are in the FSM minimum extraction region. So yeah, these two reports are taken from FSMS Ultra, and the other steps are inputs are RTL designs and the dependency files of this. So let's try to run this tool, and I will first use this, and then I will open up the graphical user interface. So I will load the tool, and here we have RTL dependency file. That's why we get there. And finally, the RTL design files, which you have here, and I click on open, and it will add all the RTL design files here. And then I will click on the verify control path security rules button, and it will provide us a second graphical user interface, a sub GUI. And I will put here the protected state. The protected state is BG0, and the authorized state means the state which should have access to this protected state is idle. And I in our paper, I have already mentioned why you should consider BG0 as the protected state and why ideal is the authorized state. And here I will just show copy this state visit order and paste it here. And then I will add the statistics file. And finally, I will add the extracted gate level STG. Okay, so after providing all the inputs, we can click on the configure ARC-FSM-G button, and then we will hit exit. It will start running the tool automatically, and in the command prompt, you will see all the reports being generated. Yeah, you see the tool is has already done its work within just 4 seconds, and we can finally close the graphical user interface and yeah, close this out. So as I have already mentioned, the tool generates the state transition graph of the annotated gate level STG. which shows us all the violations and registers. First, just have a quick overview, go through this control bus security rules verification report for gate level abstraction. And here we see MC underscore timing. It is the name of the state variable for this control FSM. It is the design module name, and state is the state variable name. And what is the size of the state register? That is 7, because this FSM has total of 66 states. So to cover all the 66 states, you must have at least 7 bits. That's why it is the state variable size is 7. And the report is also mentioning what is the protected state which has been specified by the user. The beauty of ARC-FSM-G is that it automatically uh, maps all the states which was present in the RTL code with the ones that is present in the gate level STG. And that's why you get this very nice report, and also an exhaustive report which tells you in which FSM you have some certain rule violations, and there you can look for and finally resolve them. And yeah, it is also showing us the violations here. The first violation we see here, the control bus security rule number 1 violation. And we see a lot of state transitions here, and all of these are basically coming from the gate level STG. So here we see the various Hamming distances of it, and the rule clearly mentions that you should have an Hamming distance of equal to 1. But here we see some all the different Hamming distances, which makes this FSM potentially vulnerable to fault injection attacks. And yeah, you see a lot of transitions here, and also there is a huge number of state transitions which have violated security rule number 2. For those, all of these violations, if FIF metric was equal to 1. And it is also showing us the security rule number 5 violation. And we see there also dead states exist in this state transition graph. And also unreachable states are present, and static deadlock or states with static deadlock scenario. That means R5, R6, and R7. All of these rules have been violated in this implementation. And finally, we see here the peak memory usage of ARC-FSM-G and the overall runtime to analyze all the RTL cores and also the gate level STG, and finally providing you the report. So it is really doing a lot of work. But you see, this verification method is very fast. Why? Because it is a pure static analysis based method. So it does not require any simulation to perform this sort of checks. That's why it is called static. And also you get here the idea that static methods are so much memory efficient, and also it is all of those are very fast uh, because they solely rely on the compilation based method, and also some structural analysis based purposes. And we can also see the state transition graph in graphical format. And here you see this giant state transition graph, which has not only the 66 states present in the RTL code, but also the other 62 states which are don't care states or hidden states. And here we will also see a lot of other don't care state, the don't care transitions as well. So yeah, that is a comprehensive view and how it looks like. It means that ARC-FSM-G is able to analyze not only very simple FSMs, but also a very complex control FSM like memory controller IP. That was a quick demonstration of ARC-FSM-G on the complex memory controller IP core. Thanks for hearing.